Okay, 5-4. We're going to conclude with logs. So just a reminder, logs are exponents, inverse exponents. Number 2, if I was to rewrite that in exponential form, it would be b to the m equals n, because again, if it's in log form, whatever is by itself becomes the exponent. And there are some conditions. For one, the base must be greater than 0. However, the base cannot equal 1. And then the argument, which in this case is n, that must be greater than 0. Must be positive. Okay, so number 3, and it looks like, yeah, these are just reminders, but we have to review them. So number 3, this means b to what power equals 1. Well, no matter what your base is, in order to get 1, your exponent must be 0. Number 4, b to what power is b, so your exponent must be 1. You would write this as b to what power is b to the n, so x must also be n, because they have to be the same. Number 6, in order for those two equations to be equivalent, x must be equal to y. Number 7, in order for these two equations to be equivalent, m must be equal to n. And then number 8, to put that in your calculator, you're just going to do log m divided by log b. So those are all of the old ones that we've already talked about. Okay, number 9, here's a new one. So if you have a base with a log and the exponent with the same base, they all just cancel out and you're left with just x. All right, we're going to focus mainly on the rest of these today. So we're going to be expanding and condensing logs. So since exponents and logs are similar, but they're inverses, you want to think of your exponent rules. So you would add your exponents when it was multiplication. So you're going to keep log base b the same, and you're going to multiply the arguments. So it's the opposite of exponents. When you multiply exponents, you add your exponents. When you're adding logs, you multiply your arguments. So this is subtraction, so we're going to divide our arguments. So log base b stays the same, and you're going to take x and divide it by y. All right, number 12, the power rule tells me that my exponent is allowed to come in front. It's allowed to drop down in front, as long as you have a log there. So everything stays the same except for the m drops down to the front. So in summary, when you are adding logs, you multiply the arguments. When it says to subtract, you divide the arguments. And remember, I mentioned this briefly yesterday, these are not the same. Okay, so before we expand and condense, let's talk about what you would do with the power rule. So if I want you to expand, you do the power rule last. And when it says to condense, you use the power rule first. Okay, so let's go ahead and do these questions. All right, I am going to cross off some of these. I don't even know which ones to cross off. Maybe the easy ones. No. I don't know. We'll see as we go. Okay, anyway, sorry. So we're going to expand. So if I look inside here, I have 2 arguments. I have a 3 and I have an x. I want to separate those because I want to expand them. Since they're being multiplied, I'm going to separate them by using addition signs. So log base 6 3 plus log base 6 x. And that is my answer. 18, this time the two arguments are being divided, so to expand those, I have to put subtraction signs in between them. So log base 2x minus log base 2 5. And that is going to be my answer. Okay, number 19. So yes, I do have two arguments here. I have an x and a y. And since I'm expanding, and I have an exponent or a power, I want to do that last. So first I want to separate these two by an addition sign. So log x plus log y squared. That's what I want to do first. Now I'm going to get rid of the power. So the power is going to come down to the front, but only in front of this log because only this one had the exponent. So log x plus 2 log y would be the answer. All right, so number 20, it looks like this 2 affects all three of these arguments. So I have to do something with that last. So we'll worry about that in a little bit. So it looks like these two are being multiplied, but then we're dividing by 4. So I'm going to expand this as log base 4x plus log base 4y minus log base 4. Now this 2, they also all have an exponent, so I have to go through and give them all an exponent. Okay, now I want to get rid of the power. So what I'm going to do is I'm going to drop this 2 down in front of each of these. So 2 log 4x plus 2 log 4y minus 2 log 4. Now that's one way to write it. Now since they all have a 2 out in front, you also have the option to write it like this. Just take the 2 out. Now you're probably wondering what's the point of all this? Good question. You need to learn how to expand and condense when we go and solve equations eventually. Condensing is more beneficial, but if you need to know how to condense, you should also know how to expand. Okay, so either that's my answer or that's my answer. I don't care which one. Okay, moving on to number 21. So I've got 2 arguments, and this square root of x, that's the same thing as x to the 1/2. So I'm going to change that. So since they're being multiplied, I'm going to put an addition sign in between them. And then the last thing I want to do is the power rule. So this 1/2 is going to come down in front of this log. So log base 5(2) plus 1/2 log base 5x. And that is my answer. Okay, so on number 22, let's see, I got 4 arguments. So if you have whatever's in the numerator, you're going to put addition signs in between them, and then whatever's in the bottom, you're dividing by those. So multiplied, and then you're dividing by those. So first you're going to do log a squared plus log plus log b cubed. Now I'm moving to the denominator. So I'm dividing, so I'm going to subtract log c and then minus log d to the 4th. And you might think that's addition because these are being multiplied, but you want to look at this as a whole. These are being divided by these. So if it's in the denominator, it's minus and minus. Last thing I want to do is bring down the exponent. and then you're done. So all of this is my answer. Okay, now 23 and 24, they're just like logs except they're natural logs. So I'm just going to cross those off because you do it the same way, it's just natural logs instead. Okay, now we're going to do the opposite. Now we're going to condense. So when you condense, you want to do the power rule first. So if you have a number in front of a log or a natural log, you're going to move it to an exponent. Now this one doesn't have one. So I'm going to condense it. So I'm going to make this into one log. And then dividing, or subtraction means I'm going to divide the two arguments. So that's all I have to do for that one. All right. Number 26, sorry, I had an issue going on here. Okay, so on this one I have a number in front, that becomes an exponent. Okay, and then this means we're going to multiply the two arguments. So log base 5, and then it makes more sense to put the 3 first, so 3x squared. It just looks better that way. So that's my answer to that one. Okay, moving on. Okay, we're still condensing. So I need to condense to log base 4. If I have a subtraction sign, that means division's going on. I don't have any exponents. Now the 5 is going to go on top. The x is going to go on the bottom because there's a subtraction sign in front of it. And then y is going to go on top because there's an addition sign in front of it. So that's my answer to 27. All right, 28. Okay, this has a 2 in front of it, so this becomes x squared. All right, now I'm going to condense. So log base 3. Let's see, 4 and x squared goes on top, but the 5 goes on the bottom because there's a subtraction sign in front of it. So that's my answer to 28. Okay, let's try the ones with natural logs. So I'm going to have natural log this time. These are both exponents, so this is going to be x cubed, and this is going to be y squared. Okay, this addition sign means we're multiplying, so we're going to multiply x cubed and y squared. So that's my answer to that one. And then 30, this becomes 3 squared. This becomes 5 cubed. All right, so I'm going to condense. I have subtraction signs, so that means I need a division sign. 3 squared, which is 9, goes on top. X has a subtraction sign in front of it, so it goes on the bottom. This one also has a subtraction sign in front of it, so 5 cubed, which is 125, also goes on the bottom with the x. So that's my answer to 30. Okay. Now we're going to switch to evaluate. So now I'm going to actually get answers without a calculator. So the first thing I want to do is condense. That was the whole point of expanding into condensing, is because we want to now evaluate. So I want to condense first. So this becomes log base 8. This addition sign means to multiply the two arguments together. That's what it condenses to. Okay, now I'm going to rewrite this in exponential form. So this means 8 to what power is 8? Well, my answer is 1. Okay, 32. So this time I have a subtraction sign. That means to divide. So 72 divided by 2 is 36. And I'm going to rewrite that. That means 6 squared. Whoops, 6 to what power is 36. So my answer is 2. Okay. Next, so I'm going to write this as 3 to some power equals 9 to the 4th. Okay, we haven't really seen one like this before. So that's one way you could figure this out. Or you could also do the power rule. I'll show you both ways. So first I need these to be the same base in order for me to figure out what this is. So I can change this 9 to 3 squared. But I still have a 4 there. So I just changed the 9 to 3 squared. So that's going to give me 3 to the x on the left side, 3 to the 8th on the right side. Now my bases are the same, so my exponents have to be the same. So my answer is 8. That's one way to do it. Another way to do it is to do the power rule. So what I mean by that is I can move this exponent down to the front. Okay, then I'm going to figure out what this is. That just means 3 to what power is 9, which is 2. And then I just multiply that 4 and the 2 together to get 8. So there's two different options on that one. All right, 34. So I'm going to go ahead and do what's in parentheses here. I'm going to ignore that 3 for a second. So this means to divide. So bring down the 3. And then I get log base 2, 24 divided by 6 is 4. Okay, this means 2 to what power is 4? That's 2. And then I multiply that by 3 to get 6. All right, last page. Okay, it looks like I want you to cross off 42 and 43. And we are still evaluating. Okay. All right, so I'm going to go ahead and rewrite this. And there's different ways you can do this. One way is to maybe, since they both have a 3, you could bring the 3 out in front and write this as log 2 plus log 5. So I'm going to show you two different ways on this one. And this is going to be 3 log 10, because addition means to multiply those two. When I got to figure out what this is. So if you have a log with no base, there's really a 10 there. So this means 10 to what power is 10? That's 1. And then you take the 3 that's already there times the 1, and you get 3. That's one way to do it. Another way to do it is to make these exponents. So I can make this log 2 to the 3rd plus log 5 to the 3rd. So this would be log 8 plus log 125. This means to multiply 8 and 125. That's going to be 1,000. And then you got to figure out, there's really a 10 there. 10 to what power is 1,000? That's going to be 3. So there's two ways to do that one. There's probably more than one way to do many of these, but anyway. All right, 36. So this is something you should know. You should know automatically that the natural log of e is 1. Because again, I don't have a base. There's really an e there. So this means e to what power is e? That would be 1. So this is always 1. Remember that. On this one, I can do the power rule. I can move this down to the front. This becomes 2 times the natural log of e. Well, I know the natural log of e is 1. So then I take 2 times 1, which is 2. Okay, I actually want to skip down to 40 and 41, and then we'll go back up to 38 and 39. So 37, 40, and 41 I want to keep this in mind. Okay, so I'm going to rewrite this. This is the same thing as the natural log of e to the negative first. Well, now it looks like number 37. So if I have an exponent with a natural log, I can bring it down to front. This is just 1. So negative 1 times 1 will give me negative 1. Same thing with this one. I'm going to bring the negative 2 down in front. Yes, there's already 2 there. That's fine. This is just 1. So you're saying negative 2 times 2 times 1. That's just negative 4. Okay, so that brings us back up to 38 and 39. Now these are more of not really evaluating. They're more of simplifying. So I'm just going to condense really. Sorry, there's somebody at my door. Okay, so that addition sign means I'm going to multiply the 2 arguments together. Okay, so this becomes a natural log of 30, and then I'm done. This one means to divide, so 3 divided by 12, and I can reduce that to 1/4. So that is my answer to that one. So it might say to simplify, it might say to evaluate, so you just have to pay attention to the directions.